Good morning and happy Friday. Today's first lesson is on what's called the sine law, and if you could guess, it has to do with the sine function, so not cos, not tan, just sine today. Our learning goals, we're going to use the sine law to solve for angles and side lengths of non-right triangles. So that's the key here. We're going to use sine law for non-right triangles, meaning it doesn't have a 90 in it. So compared to yesterday, we only worked with 90-degree triangles. Today, obviously not all triangles have 90 degrees in them, so we're going to use something called the sine law, which we can use with triangles that don't have 90s. And there's two versions of this formula. They're not too hard to remember, but like I said yesterday, you're going to get all the formulas on your test. You don't have to worry about memorizing them necessarily. So there's one version for sides and one version for angles. So let's start with four sides. And for sides, A over sine A equals B over sine B. So you can see with your formula, it is important for you to make sure you have, or you know the difference between small letters representing sides, capital letters representing angles. And really you just have to remember the pattern. So if you notice, small letters on top, capital letters on the bottom, and then within each fraction, A goes with A and B goes with B. You should never have those things mixed up. And then for angles, it's very similar, just flipped. So sine A over A equals sine B over B. Now I'm using A's and B's, they're just placeholders. So you might have to use C's, or if the triangle was like a DEF triangle or XYZ, you would use those letters. And the key to this, non-90 degree triangles. So as soon as you don't see that little square for 90, that means what we learned yesterday, SOHCAHTOA, and also Pythagorean theorem, which is only available as a tool on 90s, you can't use that. So for triangles that don't have 90s in them, you can't use SOHCAHTOA, you can't use Pythagorean theorem. So our first example, find side C to 1 decimal place. You don't have the handout today. It's not too bad to copy. So copy down that triangle, pause the video, and then come back to our solution. The first thing you should do when you are solving these is label all your sides. Now, since it's not 90, we don't see the square in there. You can't label your sides like opposite, adjacent, hypotenuse. Instead, capital A right across from it goes small a, capital B right across from it goes small b, and then capital C, small c. And what I like to do is I like to make this little chart, because this chart helps you determine in the future what tool to use between sine law or cosine law. And obviously this is in the sine law lesson, so we know we're going to use that, but on a test, it's not necessarily going to tell you, hey, use this. You have to decide for yourself. And then fill in your information. Side A, I don't know. Side B, I do. That's 32. Side C, I don't know, and that's what I'm being asked to find. Capital A, I don't know. Capital B, I do know, that's 60. And capital C, I know, is 40. So if you make this chart, what you are looking for is you are looking to have a complete letter, meaning you have both pieces of information. So if I look at my A's, I don't have either. If I look at my B's, I actually have both pieces of information. I have a complete letter. If you have a complete letter, that is your visual cue to use Sine Law. So I like to draw a box around it. And that is our visual cue to use Sine Law. Since I am looking for C, I'm going to use the Sine Law for sides. And so we're going to start C over sine C equals. And what goes on the other side of this equal sign is always the letter that you have complete. So always the letter that you drew the box around. And since we're starting with side lengths on top, it's going to be B over sine B because that's the complete letter. Do you have to write that step every single time? The answer is no. But for now, for you to get practice, I would write that. And then from there, it's literally just fill in all the letters, play match game. So I'm looking for side C. Sine capital C is 40. Small b is 32. Capital B is 60. Sine 60. At this point, I want to point out one typical error made. Don't forget about the signs in the bottom, like to actually write SIN in the bottom. It's called Sine Law for a reason. It's supposed to have sine in it. Oftentimes it's forgotten to put the sign, and people will just put C over 40 and 32 over 60. And unfortunately, that's not going to give you the right answer. Now the next step to solve for this, I want to get C by itself. And just like yesterday, when you have something on the bottom of a fraction, to get rid of it, you can cross multiply. So I'm going to take this and I'm going to cross multiply, which means C equals 32 so 32 sine 40, because I cross multiplied, it came to the top, over sine 60. Now take out your calculator. Hopefully you're in degree mode still. If you're not, you can ask Mr. Hack to help you get into degree mode. And you literally type it in just like you see it. So type in 32 sine 40 divided by sine 60. Again, 32 sine 40 divided by sine 60. We want to go to one decimal place. And hopefully you got 23.8 when we round centimeters. There is no kind of built-in self-check like last time where you could kind of compare it to the hypotenuse to see if you were lower or greater than that. And the other thing too, a lot of these triangles, they're just stock triangles, and I changed the side lengths and angles. So these diagrams are never to scale. So if you're thinking, well, that doesn't look like 60, or that doesn't look like 32 centimeters, or that doesn't look like it's that much shorter or longer than what it's supposed to be, just know that these diagrams are not to scale. So we just did an example of finding a side length using Sine Law. Now we're going to do finding an angle using Sine Law. Your first check, do you see that little box for 90? No. So that means SOHCAHTOA and Pythagorean theorem are out the window. We're going to go ahead and label our side lengths. Small a goes across from capital A. Small b goes across from capital B, and then small c, side c. And again, if you haven't had time to copy down this triangle, pause the video, come back for the solution. Then we're going to make this little chart. Fill in the information. I don't know side A. Side B is 50. Side C is 35. Capital A, I don't know. Capital B is 60. Capital C, that's what you're being asked to find. So at this point, again, you're going to ask yourself, do I have a complete letter? And your answer is yes, you have B complete. And whenever you draw that box, that is your visual cue to do Sine Law. Since you are looking for an angle, we are going to use the Sine Law that is for angles. So sine c over little c. And what you know to put on the other side of the equal sign is the letter that's complete. Sine b over small b. Fill in your information. Little c is 35. Capital B is 60. And side B is 50. Now when you're finding an angle, there's actually one additional step. So we're still going to cross multiply first to get rid of that 35 on the bottom. So sine C equals 35 sine 60 over 50. If you remember from yesterday, you don't just type in 35 sine 60 divided by 50. That's going to give you a decimal. Remember, when you are looking for the angle, when there is a letter here besides sine or cos or tan, you have to use the inverse. So shift, second function, then sine. So what this looks like is C equals sine inverse 35 sine 60 over 50 in brackets. And you enter it just like that in your calculator. So shift, sine, open bracket, 35 sine 60 divided by 50, close bracket, hit equals. And if we round to one decimal place, hopefully you got 37.3, and our units for angles, degrees. As always with these video lessons, this is new material, so if you have any questions or you need to go back, just hit pause, rewind a little bit, and watch something happen over again. Make sure that you're getting the same answers as me with your calculator. Our third example, we saw this yesterday, solve. And solve with triangles means find everything. I don't see the little box for 90, so that means we're not using SOHCAHTOA or Pythagorean theorem. So take a second, pause it, copy down your triangle. Label your sides with the small letters. Remember, they always go across from the capitals. Make your chart. Fill in your information. I don't know A. I know B is 70. I don't know C. I don't know capital A. I know capital B. And I know capital C. Just like yesterday with a solve triangle question, you're always finding, or going to always be finding, three different things. The easiest thing to find is angle A, which, remember, there's 180 degrees in a triangle. So if I do 180 minus 62 minus 43. So if you type in your calculator, 180 minus 62 minus 43, you should get 75. So I know angle A is 75. So there's our first easy mark. Since there's no 90s, we're not using SOHCAHTOA, we're not using Pythagorean theorem. You're going to ask yourself, do you have a complete letter? The answer is yes, you have B. So that means use Sine Law. And you're going to have to do it twice, once to find A and once to find C. So let's say you want to start with finding A. A over sine A. And then it's your completed letter, which is B. Fill everything in. Capital A is 75. B is 70. And capital B is 62. Cross multiply. A equals 70 sine, 70 sine 75 all over sine 62. Enter that just like you see it. 70 sine 75 divided by sine 62. And we got 76.6 centimeters. So that's 76.6 centimeters. Remember, you can't use Pythagorean theorem because there's no 90. So you're going to repeat the same process, but for C. Now I'm going to hope maybe after seeing it a few times, you don't have to write that first formula step. But if you need to, by all means, go for it. I'm not going to for this one. So it'll be C over sine C, which is 43. And again, it's what you drew the box around. So that would be 70 over sine 62. Cross multiply. C equals 70 sine 43 over sine 62. Type that in just like you see it. 70 sine 43 divided by sine 62. And when you round, you should get 54.1. So 54.1 and then centimeters. And those are all centimeters. And you have successfully solved the triangle using Sine Law. Our last example is a word problem. So I'll give you a second to pause it, copy down the word problem, and then we'll draw the triangle and solution together. So two ships are 15 nautical miles apart. So we'll just write 15 miles. One ship's angle to the port is 55 and the other is 45. Which ship is closer? So we'll do a P down here for port. And we'll go PQR. So one ship's angle to the port's 55 and the other's 45. If this was a test question, it wouldn't matter which one you put where. Just so we all have the same solution, let's label this one 55 degrees and this one 45 degrees. So if it's asking you which ship is closer to the port, it's asking you to find that distance. So from there to there would be side R, and then this distance, which would be side Q. And then we'll go ahead and label that side P. Let's make our chart. Oh, I'm not going to use A's, B's, and C's anymore. So P, Q, R, capital P, capital Q, capital R. Fill in what you know. That's 15. I don't know capital P. Side Q and R, I gotta find those. Q is, or angle Q is 55. Angle R is 45. So far, we haven't had this problem. If you're paying attention, we don't have a complete letter. So we're stuck. Just for a little bit, though. There is a way, though, that we could get a complete letter. Hopefully some of you see that way. If you don't, I could actually get the letter P to be complete, because this angle right here, if I know the other two angles, we've been doing this a couple times now. I know there's 180 degrees in a triangle. So 180 minus 55 minus 45 gives you angle P. So in your calculator, 180 minus 55 minus 45 gives you 80 degrees. Now I have a complete letter. And that's our Q to use Sine Law. So let's start out by finding side Q. So Q over, and I'm going to stop writing the full formula. It would be sine Q, which is 55. And then what goes on the other side of the equal sign is the letter that you have complete. 15 over sine 80. cross multiply. Q equals 15 sine 55 over sine 80. Type down your calculator. 15 sine 55 divided by sine 80. And 1 decimal place, 12.5 nautical miles. Let's do the same thing for R. So R is R over sine R, which in this case is 45. And then again, the other side of the equal sign is what you drew the box around, which was P. Cross multiply. R equals 15 sine 45 over sine 80. Type down your calculator just like you see it. 15 sine 45 divided by sine 80. And we get 10.8 nautical miles. So to actually answer the question, let's put those side lengths in. So we got Q, side Q anyway, is 12.5, and we got side R as 10.8. So to actually answer the question, which ship is closer, we're just going to compare those. Obviously, 10.8 is shorter than 12.5, so this right here is the shorter distance. So which ship is closer to the port? Obviously, it's ship Q. So therefore, ship Q is closest to the port. So next is our achievement check. Again, these aren't being collected. You are more than welcome to try these. They're good test practices, and you can take a picture of your solution and send it to me in Asia, or email, or on D2L, or show it to Mr. Hack to have him check it to make sure you're on the right track. Once you're done that achievement check, if you're doing it, you are to work on section 3.3 of your workbook. So that's it for Sine Law. Practice this. Usually it's done pretty well, or once kids get the hang of it, it's done quite well. And then the lesson later today will be on cosine law, and that will be the third and final kind of big idea from this unit that you'll have. And then when we come back on Monday, you'll have some review lessons and a test.